Okay, today we're going to be doing the first part of the fourth homework, which is actually an animal intelligence test developed by Jethro Bodine, if you ever watched the Beverly Hillbillies. And since you're looking at possums versus skunks, you can be very sure that this is an independent groups t-test. So it is a between subjects, between groups design because you have different animals, in this case, in each condition. It's interesting studying intelligence too because looking at this I misspelled the word vengeance and didn't bother to correct it, so there might be something to it right there. The first step, as always, is to set up the null and alternative hypothesis. I'll put them, well, let's see, I'll put them over here. The null hypothesis is going to be that mean 1 minus mean 2 is equal to 0, meaning that there's no difference in the intelligence between possums and skunks. The alternative hypothesis is going to be that mean 1 minus mean 2 is not equal to 0. Might be greater, might be less. This is a bidirectional hypothesis. Okay. Well, this is going to be another soup to nuts, start to finish kind of study because all we have is raw data. And so we need to find the mean, variance, and standard deviation for each group. So we will start with the possum group. And yeah, so we can start just by figuring out the some of the raw scores for this group. And so that's going to be equal, we just add all these up, and that's equal to 29. And then we can square each of these two, so we get 64 and 36, 16, 36, and 25. We're a little compressed there. And so the sum of the raw scores squared is going to be equal to 177. Okay. So let's get the mean and let's do the start with that for the possums. So for the possum, let's do our mean first. The mean is equal to the sum of the raw scores over n. Sum of the raw scores is 29. And we've got 1, 2, 3, 4, 5 possum in our study. And so the mean is going to be equal to 5.8. We will do the variance next. And variance is equal to the sum of the raw scores squared minus the sum of the raw scores squared divided by n over n minus 1. So sum of the raw scores squared, 177, minus 29 squared divided by 5 over 5 minus 1, which is going to be, if we skip down a step, 177 minus 29 squared divided by 5. Oh, wait a minute, I just did that. We'll erase that. We won't edit that part out. Let's just skip down a few steps, and it's 168.2 over 4, and that gives us 8.8 over 4, which is equal to 2. That looks like a z, so we'll say 2.2. And then for our standard deviation, it's just the root of that. 2.2 under a root sign is equal to 1.48. So that's our mean, variance, and standard deviation for the possum group. Let's do the skunks next. We'll move it down over here. The sum of the raw scores, just by adding that up, is going to be equal to 21. And then we square each of these, 16, 25, 36 and 36. And we'll put that down over here too. So the sum of the raw scores squared, there we go, is going to be equal to 113. And so we'll put that over here. I guess we can start up over here. So the skunks. We don't need to write the formula up again. We're just going to take 21 over 4. And that's going to be equal to 5.25. So we can see right away, just by comparing the means, possum are smarter than skunks. And I can say that from firsthand experience too. The question is it a statistically significant difference between the two? Let's get the variance for skunks. Again, we already have the formula here, so let's just plug in our numbers. It's going to be 113 minus 21 squared divided by 4 over 4 minus 1. So skipping on down is going to give us 113 minus 110.25 over 3, which gives us 0.92. That's what that works out to be, skipping a couple more steps. And so our standard deviation is 0.92 under a root sign, which is equal to 0.96. Okay. Our next step is going to be, so we've got the mean, variance, and standard deviation for each group. I think our next step then will be to find the standard error. So let's put that over here because we're running out of workspace. That's x bar 1 minus x bar 2. Our formula for that, which we have, is, that's kind of complicated. So we're going to have to skip some steps too. That's n1 minus 1 times the variance for group 1 plus n2 minus 1 times the variance for group 2 over n1 plus n2 minus 2 times 1 over n1 plus 1 over n2, all under a root sign. So we can fill this out. We can skip it on down to over here. So 4 n minus 1 times the variance for the possum group is going to be times 2.2. So 4 times 2.2 plus n minus 1 there is going to be 3 times 0.92, because there's our number right there, over 5 plus 4 minus 2 times 1/5 plus 1/4 under a root sign. I'll skip on down here. We get 11.56 over 7 times 0.45 under a root sign, which gives us 0.74 under a root sign, which gives us a standard error of 0.86. Okay, now we'll do t, and we'll put that up over here. This is our t obtained, and that again is equal to mean 1 minus mean 2 over our standard error. So mean 1, 5.8, minus 5.25, over 0.86. And that's going to be equal to, well, 0.55 over 0.86, which is equal to 0.64. That's a pretty low t, I can tell you that right now. Our degrees of freedom, because we need that in order to get our critical value. That's equal to n minus 1 plus n minus 1. So essentially 5 minus 1, 4, plus 4 minus 1, 3 is equal to 7. Our t critical with 7 degrees of freedom is equal to 2.365. And so because our t of 0.64 is less than our t critical of 2.365, our conclusion down here is to fail, to reject the null hypothesis, because we cannot say that there's a significant difference between possum intelligence and skunk intelligence. So we fail to reject the null hypothesis that there's no difference between possum and skunks. And that seems reasonable to me. And that is how you would do the first part of the fourth homework, which is an independent group's t-test.